planet, because just picture a double star system. Let's just say we have a binary star, and the two stars don't pass right in front of one another as seen by you, the observer, but the stellar disks just sort of graze, just look like that as they're going past one another. Well, that can simulate the small drop in light when the star in front just occults just a little bit of the star that's behind as seen by you, the observer. So then ground-based follow-up is necessary with ground-based telescopes in order to tell the difference between, for example, a binary star and a real planet. And there are many, many other astronomical phenomena that can mimic a planetary transit. So a lot of follow-up is required. So as a result, Kepler doesn't immediately identify planets. It identifies planetary candidates. And then we have to follow up to see how many of those planetary candidates are actually planets. Now, Kepler also enables you to do a number of other things with the data that I don't have time to go into, but it enables you to eliminate many of the false positives. That is, just the Kepler data themselves enable you to sort out which ones are probably planets from many that are pretty clearly not planets. So the result is that Kepler identifies planetary candidates, but roughly 90% of those, 90%, will prove to be planets. Thus far, Kepler has only confirmed about 25 planets, but we expect that of this more than 1,200 planetary candidates that were announced as of last February, we expect that at least 1,000 of those are going to prove to be planets once the follow-up work is done. And what we see is that Kepler has identified 68 Earth-sized planetary candidates, a little bit less than 300 so-called super-Earths. These are planets that are perhaps 2 or 3 times larger than the Earth. Another over 600 that are roughly the size of Neptune, perhaps another 165 that are the size of Jupiter, and then 19 that are even larger than Jupiter. So Kepler is adding to our list of planets, and Kepler is about to release some more data, which will release probably more thousands, plural, of planetary candidates. And interestingly, most of these candidates are orbiting stars like the Sun. Now, Kepler, in fact, is optimized to look at stars like the Sun, so there is something of a selection effect here. But in fact, what we are seeing is that many of these planets orbit Sun-like stars, which again means that there is great potential for there to be habitable planets and habitable environments around those stars.